Element 29 on the periodic table is copper. This is Norris Teaches Science with me, Mr. Norris, another physical science edition video coming at you right now. Today, I'm going to present to you acceleration, which is another topic in the physics section of physical science. So today, you should be able to calculate acceleration. Um, Now, what is acceleration? Acceleration is the rate of change of velocity. Remember, rate means time. So we want to see how about the time of changing your velocity. So the change of velocity in a given time. Now, acceleration is a vector, so there's usually a distance to a direction, to it, and there's a value to it. And basically, acceleration is when you increase your speed. Now, the acceleration formula is a little bit more complex than the previous formulas we talked about. I have it algebraically, but I do have it in the triangle form over to the right. The algebraic form says A equals parentheses VF minus VI, close parentheses, all of that over T, where the little a represents acceleration, which unit could be meters per second squared, or you can write it m over s over s. It's the same thing, it's just different ways of writing it. Vf represents final velocity, and it will be in meters per second. Vi is going to be your start velocity, and its unit is going to be meters per second as well. And then t is representing time, and it's going to be a second. So if you place it in the triangle, at the top you're going to have Vf minus Vi. That's something you have to do before you do any calculation. T is going to be at the bottom because you're dividing them, and A is also at the bottom as well. Remember, numbers that are on top of each other you divide, numbers next to each other you multiply. We're going to apply these in 3 examples in a moment. So deceleration is related to acceleration, or it's also known as negative acceleration. This is when you are slowing down your speed or decreasing your acceleration. Decreasing your velocity. You're going to solve it just like using the acceleration formula, but deceleration problems answers will have a negative number to them. Now, acceleration graphs do exist. You have speed versus time. Speed on the y, time on the x. This first one represents acceleration, the second one represents deceleration, and the last one represents constant speed because you're not changing your speed over the given time. But we can also express these acceleration graphs as a distance versus time graph, with distance on the y and time on the x. All right, so acceleration is a curved line up, deceleration is a curved line down, and constant speed looks just the same as it does on the speed graph because you're increasing your distance at the same time you're increasing your time. Now let's do some math here. Now when I know I'm doing an acceleration problem, the first thing I do is over to the side I write Vf equals Vi equals. Alright, very important that I identify which one's which. So it says a car starts from rest and accelerates to 20 meters per second in 4 seconds. What is the car's acceleration? So the first thing we need to figure out is what are we trying to find? And according to the question, underlining acceleration, we're trying to find acceleration. Acceleration is represented by the lowercase a, and in the triangle, it goes here. Now we look at there should be 3 more values we need. We have 20 meters per second, we got 4 seconds, but I don't see another number up here. But I do. It says a car starts from rest. Rest means 0 meters per second. So we know our time, and time goes right here in the formula. Now, we need to identify Vf and Vi. Vf is the final velocity, Vi is the start velocity. It says a car starts from rest. So this car starts at 0 and accelerates to 20 meters per second. It means the final velocity is 20 meters per second. So in the formula, we do Vf 20 minus 0. So the first thing we have to do is actually do this 20 minus 0. And if you understand that, you get 20 at the top. Now that we have our two numbers, since they're on top of each other, we're going to divide. So on your calculator that I hope you brought with you, you're going to do 20 divided by 4, and you will get 5. And then we still have to give a unit here. It's acceleration, so the unit for accelerations is meters per second squared. All right, everyone good here? I hope so. I can't see your faces. All right, let's do the second one. This time, remember when I know it's an acceleration problem, I'm going to write VF and VI to the side so I can identify them. It says a runner is going at a speed of 5 meters per second and increases her speed to 55 meters per second in a time of 25 seconds. What is the runner's acceleration? So according to this, what are we trying to find? Acceleration. So we're going to leave the little a in the formula. The other number at the bottom is time. What is the time in here? 25 seconds. Now we need to look at VF and VI. VF is the final velocity. What was the runner's final velocity or final speed? That was 55. And what was the speed before the increase? 5. So once we have that, we're going to plug that in. At the top, we're going to do 55 minus 5. Now, before we do any division, we have to actually figure that out because it was in parentheses in the algebraic form. So 55 minus 5 is 50. So at the top, we have 50. At the bottom, we have 25. When numbers are on top of each other, we divide. 50 divided by 25, you will get 2. Now, what is the unit for acceleration? It's meters per second squared. This time I'm going to write it like this because it's the same thing. All right, one more problem. Acceleration problem number 3. A train slows down from 200 meters per second to a stop in 50 seconds. What is the train's deceleration? So VF, VI to the side. Now, what are they trying to find? They're trying to find deceleration, which is a form of acceleration. So that means we're going to leave the A in the formula. At the bottom, the other number at the bottom is your time. According to this problem, our time is 50 seconds. So we're going to write 50 down here. All right, now we need to identify VF and VI. VF is the final velocity. What did the train's final speed look like? This is a trick here. Remember, it says it slowed down from 20 meters per second to a stop. Stop is the final. And when you're stopped, are you going any speed? No. So final velocity is 0, and that makes your initial velocity 200. So in the formula, we're going to do 0 minus 200 at the top. 0 minus 200 gives you negative 200. So we have negative 200 at the top. We have 50 at the bottom. We do the division. You should get negative 4, and a unit is meters per second squared. You have to have this negative sign in here because of the deceleration. But this is calculating acceleration. I really hope you learned something and come back for another video. And I'm Mr. Norris, and I'll see you at the next one.